What is up, amigos? Today we're looking at the effects of loading on a car's aerodynamics. So a car can be loaded with many different configurations. We can have one person in the car just driving along. We can have two. We can have two in the back as well, even three. We can have a full tank of gas. We can have the boot loaded up with all of our stuff, whatever. So the car can really be up to 1,000 pounds or more heavier, depending on how much we load the car up. How does that affect the actual car's geometry and then the lift and drag of the car? That is what we're looking at today. So first of all, let's say we have the car completely unloaded. Only let's say a driver is in there and a light person at that. First of all, the car's suspension will be compressed a certain amount. And also, if we look at the wheels, if we have the road here and we have the wheels touching them, as they do, where they touch, there'll be a little bit of a bulge. And this is because the rubber is flexible and it compresses and then we get this bulge happening. What happens now if we load this up? So we have 5 really big people in there. We have the boot loaded. We have a full tank of gas, everything. Well, first of all, this car will sink down. So this suspension will start to compress and the car will lower. Also, the bulge will get much bigger because the rubber will deform more. So how did those two major effects affect the lift to begin with? First of all, if we have a lower ride height, and if you don't know how the ride height affects the car's aerodynamics, check out this video here. But if we have a lower ride height, in terms of the drag, we actually get a drag drop usually of about, depending on the car, but the drag change will be somewhere between minus 20 counts and minus 5 counts, with the average being about minus 15. So that's pretty good. That means if we load the car up more, we would generally get a lower drag. However, for the lift coefficient, we see a much greater range in terms of how it changes. We actually see some reduction sometimes of minus 10 counts, but we actually see sometimes increases up to 30 counts. And it really depends on the cars. In terms of SUVs, typically we see a reduction, and in terms of sedans, we typically see an increase. So the average is maybe, let's say, plus 10. If you get any car and you just say, okay, how much does the lift coefficient change? If you assume 10 counts, that's about the average, but that's not necessarily correct. It's just the average range. So what about the drag? Well, in terms of, what about the drag of the wheel here? So we talked about the ride height, now the drag of the wheel, and we changed the wheel bulge. So this is actually a point of contention, and we don't really know exactly how it changes exactly. So one study that came out in 2018 actually showed that increasing the wheel bulge, increasing the loading, dropped the drag coefficient of the car by about 5 counts, minus 5 counts. However, this was for a treaded tire. So there were these longitudinal grooves here and there were grooves, side grooves here, etc., which help with displacing water. But if they used a smooth wheel and they changed the loading, they actually found that increasing the loading, so putting more weight into the car, resulted in an increase in the drag of about 4 counts. Now, as I mentioned, that this was just one study that's really looked into it. There hasn't been too many others that have looked into this. This is really the cutting edge of research here. So that is how loading a car up affects the lift and drag of the car and why. So if you like this, make sure to like this, and if you want to see more like this, click the subscribe button. And if you want to learn more about car aerodynamics and in particular motorsports, check out a course by JKF, which you find a link in the description. If you like what we go through here, you really love their course because they go through the theory as we go through here, plus practical applications, and they explain it very well. So I'll see you next video. Peace out, amigos.